single cells and often assumed unintelligent.
But a renowned biologist says the amoeba could indicate great potential for the human brain. What does he mean? Well, we'll tell you right after this. Unconventional scientific career, leaving graduate school even before graduating to set up an independent research laboratory. But that hasn't stopped biologist and lecturer Dr. Brian J. Ford from having a long-lasting impact on science.
Well, he has done research on mad cow disease and even had laws changed because of his discoveries. Now, we had a chance to speak to him when he was in Singapore to deliver a distinguished visitors lecture at the Singapore Science Centre. And we first started asking him just how he started out.
Talking to the man who was going to be my PhD supervisor, and I said, do you know, this whole system doesn't make any sense. How do you mean? He said. I said, well, I study a certain thing and get a PhD. He said, yes. And then when I'm 80, I'm the world's greatest ever certain thingologist. And he said, yeah, that's how the system works. Yeah. I said, well, I don't want to do that. I want to do a certain thing for 4 or 5 years, and then something totally different, and other things at the same time. And also I want to write about science and broadcast about science. And he said, look, if you're a scientist, you can't do the media. And if you're a PhD, you have to study and specialise in one specific thing. That becomes your lifetime's work. And do you know, last year, my university, Cardiff, actually appointed the first professor of interdisciplinary studies, which they said at the time you couldn't do. And the year before, they set up their first head of media relations and public relations, which they also said you couldn't do. So I thought, well, the only way to do this is to have my own lab and do it my own way. So I did. And often people imply, as you just did, that it was a very brave and forward-looking thing. No, it wasn't. It was stupid, it was irresponsible, and it was completely arrogant. It's just good fortune that it seems to have worked.
And on hindsight, now it becomes brave and because it worked out well. But you see, that's a stereotype. People say, you're a scientist. So they expect this guy in a white coat, sitting in a lab, not being able to have many friends and speak to people, and, you know, not being able to relate to the rest of the world because you're so immersed in your science.
But that's where the nerd comes from, you see. The nerdy aspect of science comes from the fact that people are taught this stuff, they talk this stuff as well as being taught it. They relate to their friends in that field, and they never have the chance to talk to the public. I was lucky because when I was going to go to university, I hadn't got enough money to do it. And therefore, I needed to have extra sources of finance. So at the time, I was playing rock and roll piano. So I used to play keyboards in a rock and roll club twice a week. And I also went to see the editor of the newspaper and said, you need a science column. So I was writing a science column, and it meant that for every Friday, I had to come back each week to thinking in terms the public would understand. So that I was not able to just retreat into a specialism. I had to talk in simple terms. And I think it was Albert Einstein, somebody will ring in and say, no, it wasn't, it was Faraday. I think it was Einstein who said that unless you understand your science, if you understand your science properly, you can explain it to your grandma. And if you cannot explain it to your grandma, then you don't understand it yourself.
Was that why you took up the challenge to bring science closer to the masses? Because that was one of your key passions. You've been hosting a lot of programs trying to make sense of all the jargons in the world of science.
Well, people often believe that jargon in science is used to help people in science communicate, but it's not. The jargon is there for scientists to excommunicate the public. In fact, I can give you an example. I've done research on blood coagulation. And with blood, you work with red cells, and you study red cells, and you count red cells. But the moment that a stranger comes into the lab, they stop being red cells, and they become their scientific name of erythrocytes. And people show people erythrocytes and talk about erythrocytes and counting erythrocytes. And when the stranger's gone, maybe somebody from the grant committee, maybe somebody's auntie, they go back to being red cells. The long words are used to keep the public at bay as much as to help communicate.
Well, I hate to say this because sometimes it's really very simple. I mean, I've spoken to a guy and he's explained the whole process, and I go, so it's basically about taking this vessel and just cutting it in half, right? And he goes, well, yeah. You know,
yes, but he's shocked when you do that because he thinks, don't do that, you're giving the game away.
Well, one of the key studies that you have done, and that's made really headlines in the world of science, is intelligent cell. What did you mean by that? Cells have feelings.
Cells do extraordinary things. If you look at cells under the microscope, which of course people don't do these days people are looking at the minutiae, they're looking at the molecular genetics of cells, they're looking at cell biology, they're looking in the tiniest way at the smallest bits of cells. Nobody's actually looking at what entire cells do. And we know that cells take decisions. At the moment, as you're sitting here, you've got amoebae in your throat. I mean, they're called white blood cells, but they're really amoebae. And they are patrolling your throat, looking out for any germs that come in. And if you inhale germs, as you have just done, certainly, because they're in the air, the white cells will, using their own cognitive powers, they will identify these germs, they will recognise that they need to be destroyed, they will communicate to their chums and gather round and destroy it. I mean, when we were in school, we all learned of amoebae as being the simplest, most lowly form of life. But there are some amoebae, and I'm doing studies of these at the moment in England, there are some amoebae that construct a home for themselves. They pick up things like tiny specks of sand and cement them into a beautiful vase-shaped house in which they live. And sometimes you can look at cells under the microscope and see that they've been damaged. And the way that they repair themselves by actually carrying out reconstruction work is much more than just a simple chemical system. Now, scientists say that if bacteria come together in groups to form what we call a biofilm, a thin film of bacteria, that the whole group can almost show a primitive intelligence. But I say, no, 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 the intelligence is within each single cell. Each cell has its own decision-making capacities. And some living cells, for example, we know that cells can respond to chemicals and to touch, which is almost like the sense of taste and the sense of hearing. But some cells within the cell have a tiny eye. They have a tiny lens and a little retina within the single cell in order to see where they're going in some strange and primitive
So
way.
all these explanations are fascinating, but what does it mean to us?
What it means to us is, at the most extreme level, this. If an amoeba can build a home for itself, then in my view it does not make sense to look at the human brain cell, as currently we do, as being a kind of a transistor, a switch, an on-off switch. That's what we're all taught the brain cell basically is. If an amoeba can do these things, then to me it's obvious that the most highly evolved cell we know of, which is our brain cells, are not just saying yes or no. I believe the brain cells are doing the thinking within themselves and not between themselves. So the conventional model is that your brain is a kind of a massive computer. My view is that each cell in your brain is the computer.
It's a computer.
So your brain is a community of computers. That means that the human brain is probably, and I'm not exaggerating, at least 1 trillion times more complex and intricate than anybody has ever begun to understand.
Who knows? We could actually have a democracy within our bodies.
We
They
have.
have a discussion, they have a chat and say, OK, let's do this. Let's work on this part of the body.
But that puts it perfectly. And what happens when you get anarchy in the body? Then you get things like cancer and multiple sclerosis. And if you wanted to use the sort of the community of the body as a model, which you did smiling, but which you could also have said in those words quite seriously, then it does explain a lot of disease processes, yes.
You know, when science is explained so easy in terms that we can easily understand, isn't it fascinating? Especially our body and
Exactly,
how the human
full of
brain
complicated
works.
parts. Well, that was Dr. Brian J. Ford, a scientist who went off the beaten path in name of science.